ISO 14001 and Environmental Management Systems EMS Training Module. Welcome back! In this session, we're moving from planning to the practical aspects of running our EMS. We'll start with Clause 7, titled Support. This clause is all about ensuring we have the right foundation, the necessary resources, competent people, communication channels, and information to make our environmental management system truly effective. It's about providing the essential tools and infrastructure that allow our environmental plans to become a reality. Clause 7.1 is straightforward. Resources. It requires the organization to identify and provide all the resources needed to make the EMS work. This isn't just about money. It includes people, ensuring you have enough staff and that they are competent. It covers infrastructure, your buildings, the machinery, utilities like water and electricity, and even waste treatment facilities. Of course, financial resources are crucial. Having a dedicated budget for environmental initiatives, training, monitoring equipment, and maintenance. And finally, even natural resources themselves. Managing your access to and consumption of water, energy, and raw materials. For example, providing resources might mean allocating 5 lakh rupees in your annual budget for a new wastewater treatment plant upgrade. It could be hiring a dedicated environmental engineer or formally assigning EMS responsibilities to existing staff members. Or it might involve a physical upgrade, like installing new LED lighting across your factory to reduce energy consumption. Next is Clause 7.2, Competence. This is vital. It's about ensuring that everyone who performs tasks that can affect your environmental performance has the necessary knowledge, skills, and experience. You need to identify what competence is required for each role. Next is Clause 7.2, Competence. This is vital. It's about ensuring that everyone who performs tasks that can affect your environmental performance has the necessary knowledge, skills, and experience. You need to identify what competence is required for each role. For instance, a wastewater treatment plant operator needs detailed knowledge of water chemistry, different treatment processes, specific permit limits, and emergency procedures for spills. A factory floor employee responsible for waste segregation needs to be able to identify different waste types and know the correct segregation procedures. An EMS internal auditor needs to understand the ISO 14001 standard inside out. Be skilled in auditing techniques and have a good grasp of environmental regulations. Once you've identified these needs, you must ensure that people either already possess this competence or acquire it through education, training, or experience. And you must evaluate if the training was actually effective. Training is a primary way to build competence. It can be formal courses, hands-on on-the-job training, workshops, or even mentoring by experienced staff. For example, you might provide specific training on hazardous waste handling procedures for your warehouse staff or spill response training for all production personnel. On a broader level, all new employees should receive general EMS awareness training during their induction to understand their role in the company's environmental commitment. Building on competence, Clause 7.3 stresses the importance of awareness. It's not enough for people to be competent. They need to understand why their environmental actions matter. Everyone working for the organization needs to be aware of 4 key things. The environmental policy. What is the company's overall environmental commitment? Their significant environmental aspects and impacts. How does their specific work interact with the environment? Their contribution to the EMS's effectiveness and the benefits of better environmental performance. How do they make a difference? And finally, the implications of not conforming to EMS requirements. What happens if they don't follow procedures? This could be anything from environmental damage to potential fines. Why is this awareness so important? It empowers employees to make environmentally sound decisions in their daily tasks. It reduces risk because there are fewer incidents caused by carelessness or lack of knowledge. It leads to improved performance as everyone contributes directly to achieving environmental objectives. And it fosters a positive, proactive environmental culture within the organization. Think of it this way: a cleaner isn't just emptying bins. They know exactly which bin is for general waste and which for recycling, because they are aware of the waste segregation policy. A machine operator understands that a small leak can significantly increase water consumption and knows exactly who to report it to. An IT staff member consistently turns off monitors at night because they are aware of the energy conservation goals. Clause 7.4 is about communication, which is essential for any system to work effectively. You need a process for both internal and external communication related to your EMS. Internal communication is about ensuring information flows smoothly within your organization. Purpose: to keep everyone informed about the EMS. Topics: this includes the environmental policy, objectives, everyone's roles and responsibilities, significant aspects, your environmental performance data, any non-conformities, and opportunities for improvement. Methods: you can use regular team meetings, your company intranet, notice boards, emails, internal newsletters, or toolbox talks, where specific environmental topics are discussed on the shop floor. Example: imagine monthly departmental meetings where environmental performance figures are reviewed and new waste reduction initiatives are announced to all teams. External communication focuses on sharing relevant EMS information with external interested parties. Purpose: to be transparent and responsive to those outside your organization. Topics: this could include your environmental policy, information about your significant aspects, if appropriate to share publicly, your overall environmental performance, how you respond to external inquiries, and your compliance status. Methods: your company website is key. Annual sustainability reports, public meetings, press releases for major environmental achievements, and direct responses to inquiries from regulators or the local community. Example: publishing an annual sustainability report on your company website, showing your carbon footprint reduction and waste recycling rates, or promptly responding to a local community's query about noise levels during night shifts. To ensure effective communication, your organization needs a clear communication process. This process should define what information will be communicated, when to communicate it, is it daily, weekly, monthly, or as needed, to whom it will be communicated, which specific internal or external parties, how it will be communicated, via email, meeting, report, website, and who is responsible for doing the communication. For example, you might have a documented procedure that states, any significant environmental incident will be communicated internally via email to all staff within 2 hours, and externally to relevant regulators within 24 hours, as per legal requirements, by the environmental manager. This clearly defines the what, when, whom, how, and who for critical communication. Finally, for Clause 7, we have documented information. Clause 7.5. This is where all your plans, procedures, and records come together. The standard doesn't demand excessive paperwork, but it does require what's necessary to ensure your EMS is effective. This includes your policy, objectives, scope definition, operational control procedures, records of training, audit reports, and management review minutes. When creating and updating documented information, you need to ensure identification and description, clear titles, dates, and authors. Format, whether it's paper or electronic. Review and approval. a system to ensure documents are accurate and approved before use. Then comes the control of documented information. This is vital to ensure that information is available, suitable for use, protected, and used effectively. This means availability and suitability. People can access the right version of the document when and where they need it. Protection against unauthorized access, improper use, or changes. Distribution, access, retrieval, use, clear rules on who can see, find, and use what. Storage and preservation. How long is it kept, and how is it preserved? Control of changes, implementing version control so you know which is the latest approved document. Retention and disposition. How long records are kept, and how they are eventually disposed of. And finally, controlling external origin documents, like legal acts, to ensure you're working with the most current versions. For example, your waste management procedure might be a document with a unique number and revision date, approved by the EMS manager, available electronically on the intranet, and updated annually. A monthly energy consumption log would be a record, dated and signed by the facility supervisor, stored for a specific period like 5 years, and regularly used to track your performance against energy objectives. Now we move into Clause 8, Operation. This is where all the planning we did earlier in Clause 6 comes to life. This clause is all about the practical, day-to-day implementation of your EMS. It focuses on the controls and processes you need to put in place to manage your environmental aspects and impacts effectively. Think of it as the do phase of our Plan, Do, Check, Act cycle. Clause 8.1 is about operational planning and control. This is where we ensure that the processes we need to meet our EMS requirements and implement our plans from Clause 6.1 are actually established, implemented, controlled, and maintained. It often means having documented procedures for critical activities that can impact the environment. The core of this is establishing controls for significant aspects. For every significant environmental aspect we identified earlier, we need to put specific operational controls in place. These controls are designed to prevent or at least mitigate any adverse environmental impacts. We often think about these controls using a hierarchy. 1. Elimination. Can we simply remove the activity or the aspect entirely? For example, stopping the use of a highly toxic chemical. Second, substitution. If we can't eliminate, can we replace it with a less impactful alternative, like switching from solvent-based paints to water-based paints? 3-point engineering controls. These are physical changes to equipment or processes. Installing a filter on an exhaust stack to reduce air emissions or soundproofing a noisy machine. 4. Administrative controls. These are your procedures, work instructions, or permits. A no-waste policy, a detailed standard operating procedure, SOP, for handling hazardous materials, or regular equipment maintenance schedules. 5. Personal protective equipment, PPE. While primarily for safety, sometimes it has an indirect environmental benefit, like using gloves for chemical handling to prevent skin exposure and potential spills. Let's illustrate with examples. For the significant aspect of air emissions from a paint spray booth, controls would include installing a regenerative thermal oxidizer, RTO, to burn off volatile organic compounds, VOCs. That's an engineering control. You'd also develop a procedure for cleaning spray guns that minimizes solvent use, an administrative control. And ideally, you'd use low VOC paints. That's substitution. For hazardous waste from an R&D lab, controls could be implementing strict segregation and labeling procedures. An administrative control, using smaller quantities of hazardous chemicals in experiments. That's a form of elimination or reduction. And contracting with a licensed hazardous waste disposal company. Also, an administrative control to ensure proper disposal. We discussed the life cycle perspective when identifying environmental aspects earlier, and it reappears here in Clause 8.1. When you're planning your operational controls, you must again consider the environmental impacts throughout your products or services' entire life cycle. It's about looking beyond just what happens within your factory gates. This means considering environmental requirements for design and development. Can you design products that are easier to recycle or more energy efficient during use? This is often called eco-design. Procurement. What are your environmental criteria when selecting suppliers? Are you choosing suppliers with environmental certifications or who provide low-impact materials? Delivery, provision of products and services. How does your service delivery itself impact the environment? Are you optimizing delivery routes to reduce fuel or using less packaging? End of life. What information do you provide for end-of-life treatment? Do you have clear instructions for recycling or even take-back schemes for your products? Let's take a smartphone company as an example for operational control with a life cycle perspective. In design, they might introduce a modular design that makes phones easier to repair and components replaceable, directly reducing e-waste at end of life. For procurement, they might implement a policy to only buy rare earth minerals from suppliers who guarantee responsible mining practices, thus reducing the mining impact. In delivery, they use minimal recyclable packaging for product shipping, minimizing waste. And at end of life, they actively provide free take-back and recycling programs for old phones, ensuring responsible disposal and material recovery. The final part of Operation Clause 8.2 is emergency preparedness and response. This is critical. It's about being ready for potential environmental emergencies. You need to establish, implement, and maintain processes to prepare for and respond to these situations. First, you need to identify potential emergency situations. What kind of environmental emergencies could occur at your facility or as a result of your activities? Consider types of incidents. This could be spills, chemicals, oil, fuel, fires that have environmental consequences like toxic smoke, explosions, natural disasters like floods or earthquakes that might damage your environmental controls, or equipment failures such as your wastewater treatment plant breaking down. Severity. How bad could the environmental impact be if this happened? Likelihood. How likely is it to occur? Location. Where exactly could this happen within your operations? For example, a chemical manufacturing plant might identify potential emergencies like a large chemical spill from a storage tank, a fire in a solvent storage area leading to toxic fumes, or the failure of their effluent treatment plant causing the discharge of untreated wastewater. A construction site might identify a fuel spill from machinery or the release of sediment into a nearby river after heavy rain as potential emergencies. Once you've identified potential emergencies, the crucial next step is to develop and test response plans. For each scenario, you need a specific, actionable plan. These plans should cover roles and responsibilities, who does what during an emergency, emergency contact information, both internal contacts and external ones like fire services, police, and environmental authorities. Specific action steps, what to do immediately, how to contain the incident, mitigate its impact, and eventually clean up. Resources needed, listing specific equipment like spill kits, fire extinguishers, personal protective equipment, PPE, and communication equipment. Training. Regular training for personnel on these emergency procedures is vital. And critically, testing or drills. You can't just have a plan, you need to practice it. This means conducting mock drills, tabletop exercises, and regularly reviewing their effectiveness. updating them based on lessons learned. Let's take the scenario of a chemical spill on the factory floor as an example of a response plan. Immediate action. The first responder would isolate the area and, if safe, stop the source of the spill. Notification. Immediately inform the environmental manager and shift supervisor. Response team. A trained spill response team would deploy spill kits containing the spill using absorbents. External notification. The environmental manager would notify the local environmental authority if the spill volume exceeds the reportable quantity. Cleanup. Contaminated materials would then be handled and disposed of following hazardous waste disposal procedures. Review. After the incident, a full investigation would be conducted, and the plan's effectiveness would be reviewed and updated. Testing. This plan would be tested through annual mock spill drills, and emergency contact lists would be reviewed monthly to ensure they are current.